this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic divide and conquer in the design and analysis of algorithms course. Let's start the topic. So first we'll see what is divide and conquer. So the most well-known algorithm strategy, design strategy is divide and conquer. So here we'll divide the instance of problem into two or more smaller instances, then solve these smaller instances recursively and obtain solution to the original instance by combining these solutions. So this is the general introduction of divide and conquer. So let's see what is actually divide and conquer is. So divide and conquer, it is really a problem solving technique that breaks a larger problem into the smaller ones, solving the sub-problems independently and then combining the solutions of these sub-problems to get the solution of the larger problem. So what are the stages here? Initially, this divide and conquer strategy is divided into three stages: divide, conquer and merge, or you can say combine. So let's see what is divide, conquer and combine separately. Divide. So break down the original problem into smaller sub-problems. Each sub-problem should represent a part of the overall problem. The goal is to divide the problem until no further division is possible. That is, we have to have the minimum low value as possible. Conquer. Solve each of the smaller sub-problems individually. If a sub-problem is small enough, often referred to as the best case, that is, directly we'll get the answer, we'll solve it directly without further recursion. The goal is to find solution of these sub-problems independently. Then comes combine, or we can say merge. So here in merge, you have to combine the sub-problems to get the final solution of the whole problem. Once the smaller problems are solved, we recursively combine their solutions to get the solution of the larger problem. The goal is to formulate a solution for the original problem by merging the results from the sub-problems. So the applications of divide and conquer, we all know it as it can use in various algorithms like sorting techniques like merge sort, median finding, min and max finding, matrix multiplication. You can also use in Stratian's multiplication as well, and in the closest pair algorithm. So here are some examples of the divide and conquer approach. So maximum and minimum problem, binary search, sorting we can use for merge sort, quick sort, tower of finite recursive algorithm also we can use this divide and conquer strategy. So basics or the fundamentals of divide and conquer strategy. There are two fundamental things to be used in divide and conquer. One is relational formula and the other one is stopping condition. So what is meant by relational formula? It is the formula that we generate from the given technique. After generation of formula, we apply DNC strategy, that is, we break the problem recursively and then solve the broken sub-problem. Stopping condition, when we break the problem using divide and conquer strategy, we need to know that for how much time we need to apply divide and conquer. So the condition where the need to stop our recursion steps of DNC, that is divide and conquer, is called the stopping condition. So applications, we all know the applications. Binary search, we can use in binary search or in any sorting algorithms like quick sort or merge sort. So initially what we do in binary search, we will be dividing into two halves and then find the best one. In quick sort also, we will divide the problem into smaller instances and then we will find the pivotal element and then sort the algorithm. In merge sort, we will again divide into n-2 median parts and then we will do the sorting. Same way, the closest pair point, it is a problem for computational geometry. Then the Stratian's algorithm, it is an algorithm for matrix multiplication. Then Curie-Tukey fast Fourier transform algorithm is named after him. It follows driven and imposes a complexity of order of n log n. Then Karatsuba algorithm for fast multiplication. This is also used to multiple two n-digit numbers in such a way to reduce into most single digit. So when we take the advantages of divide and conquer, it tends to successfully solve one of the biggest problems such as Tower of Hanoi, a mathematical puzzle. It uses cache memory without occupying much space because it solves simple problems without the cache memory instead of accessing the slower main memory. It is more proficient than its counterpart brute force technique. Since these algorithms inhibit parallelism, it does not involve any modifications and it can be handled by any incorporating parallel processing processor. Disadvantages are these algorithms are designed by incorporating recursion, so it necessitates high memory management. An explicit stack may overuse the space. It may even crash the system if the recursion is performed rigorously greater than the stack present in the CPU.